Greetings, Earth and Space Explorers. Welcome to Doc Waller's Earth and Space Report for Friday, July 22, 2022. I'm your host, Bill Waller, an astronomer, science educator, and communicator, coming to you on a hot and humid summer evening in my hometown of Rockport, Massachusetts. These Earth and Space Reports are intended to engage and inform people like you who are curious about Earth as a planet, who care about our life-sustaining environment, and who wonder about the greater cosmos, including our place in space and moment in time. Video recordings of these reports are archived on the Earth and Space Reports YouTube channel. They are also in regular rotation on the 1623 Studios Community Access Cable Television channel. I am grateful for the continuing interest and support shown by Rockport educators and students, Cape Ann cultural colleagues, cohorts of the Gloucester Area Astronomy Club, sundry Earth and space scientists and educators, far-flung friends, family, and other curious folk. Thank you for participating. This evening, we are joined by Dr. Jerry Bonnell, co-founder of the popular Astronomy Picture of the Day online service. Jerry received a PhD in astronomy from the University of Maryland at some point during the last century. He has since enjoyed working on a variety of astrophysical satellite projects at NASA's Goddard Space Flight Center, including the Cosmic Background Explorer, the International Ultraviolet Explorer, the Compton Gamma Ray Observatory, and the Fermi Gamma Ray Space Telescope. While his research interests have wandered across the entire electromagnetic spectrum, they have most recently focused on the time histories and spectral evolution of cosmic gamma ray bursts. Author of popular books, reviews, and magazine articles on astronomy and high-energy astrophysics, Dr. Bonnell is also a founding editor and author of Astronomy Picture of the Day, otherwise known as APOD. That began in 1995. That's a 27-year legacy of daily images, each with cogent scientific descriptions. Jerry lives with his wife, an art historian, in Greenbelt, Maryland. He and I first became friends during my time at NASA Goddard Space Flight Center. Indeed, his family hosted our young family for many delightful kiddie parties and more adult soirees. I remain eternally grateful for their kind hospitality over the decades. Jerry's presentation today, Postcards from the Universe, will look back on favorite astronomy and night sky images featured on APOD over the last year and decades. So without further ado, the Zoom platform is all yours, Jerry.
Thanks, Bill. No, hang on. That was the wrong button.
Oops, wrong button.
I'm going to try this.
Okay.
Is that working?
Yes, it's working. It's not yet the full thing. There you go.
Did we get it? Good.
You got it.
Sorry about that. Yeah, thanks, Bill. I just admit it right off. Most of my talks about Astronomy Picture of the Day are called Postcards from the Universe. For some reason, I sort of like the travel metaphor. But really, Astronomy Picture of the Day is a website that I started with my colleague Bob Nemiroff, as Bill said, in 1995 at Goddard Space Flight Center. It's become a very popular astronomy website. I think it's very simple. It's an astronomy picture a day, and it's really it's turned out that it has even managed to engage the public and amateur astrophotographers and interested types in NASA's sort of endeavors. And I think really it's gotten to be popular partly because since the 1990s, the amount of CPU power that you can put on your desk for image processing, or the detectors that you can buy and put on your telescope, have really really blossomed. Used to be those sorts of things required institutional budgets, but really reasonably well-heeled, devoted amateurs can afford this stuff now and enjoy playing with NASA images and seeing the NASA images. So I'll show you some pretty pictures from Astronomy Picture of the Day. Really, the bottom line is that's what this is going to be about. The title slide there is Apollo 14 heads for home. Apollo 14 mission was in, gosh, I've got to check my notes. Even that was quite a while back. It says February 1971. And the images are available in an archive, and this one sort of reminiscent of the famous Apollo 8 Earthrise image. This one was reprocessed by an amateur and featured on Astronomy Picture of the Day not too long ago. Yeah, let me try this. I found this snapshot of Bob Nemiroff and I from 1995, working in our office at Goddard Space Flight Center. Bill, I don't know if you remember Building 1. Building 1 doesn't really exist anymore, but it had really nice light. And anyway, you can see us in the office there. This is Bob. This is me. This is the picture on the wall is the Compton Gamma Ray Observatory. We were both part of the Compton Gamma Ray Observatory Science Support Center back then. And that's when we sort of started doing the APODs. Just a historical note. I really like this. This is a sort of an example of images we have submitted to us. In the past, back in 1995, we usually relied very heavily on NASA's archives of images and Hubble images for our daily picture. But these days we get a lot of submissions from amateurs. This is very much like this is one of my favorites in recent times. It's called The Galaxy Between Two Friends. It was taken, the photographer Martin Lefranc was hiking with his friends in the French Alps one summer, I think just last summer actually. In the picture here, the moon has just come up. So the moon this is actually a night sky photo, as you can see. The moon is what's illuminating the foreground in the image. But looking at this, I was really struck by the very extragalactic perspective presented in this. This is, of course, this is Perseus. This is probably Cassiopeia up here. This is our this is the sort of density of stars here on the left. If you can see where I'm putting the cursor is our Milky Way galaxy, basically. And so that's what the plane of our Milky Way galaxy looks like in our sky. This is this faint little cloud, this faint little smudge is the Andromeda galaxy, the M31. It's about 2 million light years away or so. It's probably the most distant thing that you can easily see with your eye at night. And it turns out, I don't think the photographer was aware of it at the time, but this smudge between the two friends, oh, I just lost my cursor, is the Triangulum galaxy, M33. So it is actually another extragalactic object, more distant than M31, a little smaller. These three galaxies here, M31, M33, and the Milky Way, are But they're the largest galaxies in our local group, in our local galaxy group. Andromeda is actually the largest galaxy, Milky Way second, M33, the Triangulum galaxy third. Anyway, it just struck me that there's such a simple scene, a simple picture, very, very extragalactic perspective almost on the universe. A good example of an amateur contribution to Astronomy Picture of the Day. Of course, in about well, look at the it's an illustration in the upper left. It's what that scene might look like in about 5 billion years. This is in about the Milky Way and the Andromeda are actually on a collision course. M31 has a blue shift for its local motion, not a red shift, as do more distant external galaxies. And in about 5 billion years, it will be here. It will collide with the Milky Way. It will interact with it. And our sky might look something like this. This is supposed to be the plane of our galaxy here, the Milky Way, and the distorted disks of Andromeda. When galaxies collide, the stars don't really collide. They're too far apart, but the gas and dust between the stars do, and the giant molecular clouds certainly collide. And the galaxies interact gravitationally, so their gravitational fields distort and influence the collision. So 5 billion years from the galaxy between two friends, the night sky might look like this. This is I included this image in the lower right of the Triangulum galaxy, the faint fuzzy dot there. That's a telescopic view of the galaxy between two friends. I've noticed that what would you call this galaxy, this merging between the Milky Way and Andromeda? People have suggested that might be called Milkdromeda, the Milkdromeda galaxy. And I tried to think of something you would call, of course, the galaxies in the local group, these large galaxies will all come together over time. And so I tried to think of what you would call the Triangulum plus Milkdromeda galaxy. So Trimilkdromeda is all I could do, but you guys would probably do better. I'll try to get another slide. Oh, Mars is a popular topic in Astronomy Picture of the Day, although amateurs, I have to admit, institutions which can launch spacecraft to explore the surface of Mars sort of have are the only source of images from the surface of Mars. Still, it's pretty exciting. This is from the Perseverance rover touchdown early last year, I think, in February last year. The image in the upper right here, this is actually the rover being lowered to the surface of Mars by the rocket-powered sky crane, which is how NASA lowered this pretty big, that's the size of a car easily, an SUV or something, this pretty big rover to the surface of Mars. So you're just looking down on it. These cables are 20 feet long or so, taut cables lowering the thing down to the surface. Here's a sort of electronic umbilical cord. I was fascinated by this picture because the camera that recorded the image you're looking at is obviously on the sky crane, but it's being driven and the images are being recorded by the computer on board the rover. So this image is flowing through this cable essentially to the computer on the rover. The rover is just a meter or so above the surface of Mars at this point, and you can see the rocket engines from the sky crane are sort of blasting these streamers Martian soil across the frame there. Pretty exciting view. It's a frame from a video that you can watch of the sky crane lowering Perseverance to Mars, to the surface of Mars. And of course, these cables were cut and the sky crane flew away and crashed at a distance reasonably far from safely far from the landing site for the rover. I put this other little inset in. This is a selfie that Perseverance took on Mars shortly, a few sols after the landing, and just after it deployed. This little guy is the helicopter. So there's essentially a remotely operated, a drone helicopter operating on the surface of Mars. See if I can. And as I say, it's hard for amateurs to take pictures from the surface of Mars, but there's certainly a lot of amateur images of phenomenon on planet Earth that also go on Mars. This the top image here is from Curiosity, another rover that's been there for a few years now on the Martian surface. Not Perseverance, not this recent one. This is an image from Curiosity taken from its location one Martian day just after sunset. So the sun's actually below the horizon in the picture, and you see these shining clouds. These we would call them noctilucent clouds, I think, on planet Earth. They're still they're far enough above the surface of Mars that even though the sun is below the horizon from the perspective of the rover, the clouds are still reflecting sunlight. I see, excuse me, carbon dioxide clouds. Carbon dioxide ice, I think, rather than water ice. But still, we have a similar thing going on planet Earth. It happens at high latitudes in the summer. This is an example of, I think this is just from a small lake in Canada, from Justin Anderson, an amateur image of noctilucent clouds. These are the night shining clouds. Also on planet Earth, they're essentially at pretty much the edge of the top of the mesosphere, sort of the edge of space, as it were. And they're still far enough above the horizon that even though this is near their local midnight at these high latitudes there, and the sun is below the horizon, they still reflect the sunlight. I see Justin has another summer illuminating phenomenon in the picture. I see little specks here in the foreground from lightning bugs. I would call them lightning bugs. Fireflies, maybe. I'm not sure what we do on the East Coast or the Northeast. Both these images are from amateurs. Here's one from the Swiss Alps in the summer, although it looks like it might be from Mars. And in fact, the dust from the Sahara Desert blows towards Europe, is blown towards Europe in the summer. Huge clouds of dust come across from the Sahara Desert, and it really does turn the sky this nice sort of pale orange is not the right word. I need another word for that color. I can't think of it. Anyway, it's the same reason that Mars atmosphere looks like this. It's scattering from the dust, from fine dust lofted in the atmosphere. You can see this is a ski resort. I sort of see the poles along the road here, and the sun. Of course, the sun on Mars would be. It looks a little bluish here, also because of the scattering by the dust. It would look a little bluish on Mars as well, although the sun would be a little smaller in in the Martian sky. The other inset, or the other image here is actually it's an all sky image, but I suspect you're used to looking at all sky images centered on the zenith overhead. This one has been projected centered on the nadir, right? The spot directly below the camera in this case. And the camera in this case was located in the Atacama Desert in the Andes in South America, a place which looks a lot like Mars, a lot like the surface of Mars. Mm. So Robert Barca called this a little like Mars. It's a distorted, that's actually called a little planet projection. But you definitely see the southern hemisphere sky there. I don't know if you recognize the constellation of Orion, but it's sort of upside down in that projection. And large Magellanic Clouds and small Magellanic Clouds, I think. Anyway, that's the southern sky over the Atacama Desert, which does look a little like Mars. Comets are also another popular topic for amateur images submitted to APOD. I set up this pair. This is actually comet Churyumov-Gerasimenko, comet 67P. It's a periodic comet. It has an orbital period of about 6.5 years, something like that. And this is an amateur image of it from late last year, when it was near perihelion, near its closest approach to the sun. So the comet develops a nice greenish, almost greenish tint coma, and hundreds of thousands of kilometers in size here. In a few light minutes at this point from Earth, and this nice long dust tail. I apologize if something horrible happens here. My computer's currently making a high-pitched whining noise.
Oh no.
Here we go. But quickly, comet Churyumov-Gerasimenko near perihelion, near its perihelion. It was never it's a periodic comet. It was never a comet you would see with your eyes. So this is obviously a deep telescopic image from an amateur.
Why so green?
Why so green? That's interesting. I think that's so the ices from the surface of the comet nucleus, which you don't see the nucleus here, right? You don't resolve it. You just see the coma. Ices from the surface of the nucleus sublimate in the sunlight. When it comes, they're heated in sunlight and sublimate, and all sorts of diatomic molecules are forming in this coma as it expands. And I think that in particular, this green tint is C2, two carbon, two atom, a molecule that's made of 2 carbon atoms. And the carbon, they fluoresce in this. So they're excited by the ultraviolet radiation, and they fluoresce in the sunlight. And I think that's what gives you that green tint.
Thank you. Thank you.
Sure. And it's the dust. I don't know if I mentioned, it's a sort of whitish dust tail, which tends to lag behind the comet a bit and generally point away from the sun. This is comet 67P Churyumov-Gerasimenko. Churyumov and Gerasimenko were the astronomers that discovered it. It's the 67th comet on the list of periodic comets, so it's 67P. It's also called Rosetta's comet. Rosetta was a European Space Agency mission to visit this comet nucleus. They could, it's a periodic comet. They can predict the orbit of the comet. They put together a mission to rendezvous with the comet nucleus, the Rosetta mission. This is I call it a selfie from Rosetta. The Rosetta mission. This is the spacecraft in the foreground here, the Rosetta spacecraft. This is the solar panel, a solar array sort of extending out here. You see it sort of glinting in the sunlight. And this is the cometary nucleus. My notes say that that's about 16 kilometers from the camera. And it's sort of a double lobe nucleus. It's not just a solid piece. It looks almost, some people thought it looked a little bit like a rubber duck. I don't know. It's got two lobes, two major lobes. And so this is the nucleus of this comet. It turns out Rosetta orbited the comet for a while, and then when it headed back out to the outer solar system, sort of towards the orbit of Jupiter and beyond, the European Space Agency drove they had a lander that did land on the cometary nucleus, but they also drove this orbiter down and touched just to touch the nucleus. And so there it remains to this day. This 6 years later was when this amateur image was taken. So this is the sort of final resting place of the Rosetta mission, hardware anyway, on the nucleus of the comet. I thought that was kind of cool. That comet was near perihelion late last year. We don't have really bright comets going on this year. So much. This is about the brightest one so far. It was discovered by the Pan-STARRS survey project, and so it's sometimes called Comet Pan-STARRS, but there are actually many Comet Pan-STARRS. This is the most recent Comet Pan-STARRS. The designation it says here is 2017 K2. C2017 K2 is not a periodic comet. This comet is from the Oort cloud. This is its first time through the inner solar system. The Oort cloud is this very distant icy reservoir of comets and objects that, well, for example, the New Horizons mission, after it flew by Pluto, flew by the distant objects. Comets are, this is sort of a reservoir of comets, as I say, for the inner solar system, but they have such long nearly hyperbolic orbits that they're probably not periodic in any reasonable sense. Millions of years to orbit, I think. Anyway, the gorilla in the room or whatever, that's a Messier cluster, M10, a popular telescopic object. I don't know if you've seen M10. Globular star cluster. And this is sort of, this is interesting. This is this comet's sort of Messier moment. It's sharing the field of view with Messier 10. I don't know if you realize this, but Charles Messier was the astronomer for which has the famous catalog of bright nebulae and star clusters and galaxies. He was a comet hunter, and he made his catalog in the 18th century. He wrote down the coordinates of all the objects he saw in the sky that he knew weren't comets. So if he saw a fuzzy object in his telescope, he could look up, but he could determine its coordinates and look it up in its catalog and see if it was a comet or not, or if it was an already cataloged object. So Messier was a comet hunter. There's M10. There's a comet having what I call its Messier moment as it heads through the inner solar system. I hope some of that made sense. This is from,
Yes, it did.
This one's about exoplanets, actually. 51 Pegasi was the first, and I have to be careful exactly how you say this, but I think you would say it was the first sun-like star discovered to have an exoplanet. The discovery was, and 51 Peg is there's Pegasus, the constellation outlined for you behind the observatory dome. That's the dome of, what is that? The dome of, it's the Observatoire de Haute-Provence in Paris, in Paris, in France, anyway. This was the observatory that Mayor and Kellis used to detect their instrument, their spectrograph was in that dome on that telescope, and they detected the wobble, the Doppler wobble in the spectrum of 51 Peg that alerted them to the fact that it had a planet, an exoplanet. It was the, as I say, the first discovery of an exoplanet around a sun-like star using this sort of Doppler wobble technique. And how far is that away? Well, that's 50 light years. It's 50 light years to 51 Pegasi. Of course, now many other there's thousands of other. There's 4,000 or better known exoplanets detected by this wobble technique, the spectroscopic technique, or an occultation technique, looking for the dimming of host stars that's caused when the planets pass in front of it. This was the Nobel Prize in I don't know, 2015, something like that. The great discovery. I like this pair. So the big image is of, speaking of globular star clusters, the big image is M13, an amateur image from Martin DeFore. Star, I don't know, 10,000 light years away, 13,000 light years away. Maybe I've managed to put that down in my notes. Yes, I have. It's 25,000 light years away. And in this region, I have, in this region, which is about 150 light years across, there are, I would say, there are 100,000 stars. 100 stars, say, would just be in a cube 3 light years on a side. Three light, well, it's a little over 3 light years. In our neck of the woods, it's 4 light years to the nearest star system, Alpha Centauri. So the stars are very densely packed in the core of this globular star cluster. This is from a reserve in upstate New York, submitted by Roger Hopkins. He called it a flock of stars. And imagine that if he lived on a planet, an exoplanet, if he lived on a planet at the center of the globular star cluster, what might his night sky look like? Of course, he's manipulated the image. What he's actually photographed is a flock of starlings leaving the lake, and he's simply inverted the black starlings to make the white spots as the sun set and the stars come out. The densely packed sky full of stars come out. Here's a let's do a couple of these. These
Beautiful.
images were made. These are both Earth-based telescopic views of star-forming regions. Actually, the one on the left, this is M16, and the Eagle Nebula. And I think it would look slightly more like an eagle to your eye in a wider field of view. These are stellar nurseries. This is a very famous structure, famous from the Hubble photograph, called the Pillars of Creation. I think the idea is that these are dense pillars of dust being eroded by the hot stars formed in this cloud. And as they are eroded away, it reveals that within the pillars, stars are being formed. There are stars condensing from dense cores in these structures. These are light years. This is 20 light years or so across. So this is quite a cosmic structure. Stars of a stellar nursery where stars are formed. This one on the right is a similar sort of thing. This is like one of those pillars in the Eagle Nebula. A popular, I guess, thing to do with your astro image these days is to photograph the nebulae and remove the stars, remove the point sources from the image, and just leave the gas, the sort of natal gas and dust. Of course, Robert Ader has taken all the stars he can see out of this image, but the stars that he can't see are the stars that are forming down in the dense clouds. This is a popular. I think it's identified as IC 1396 or something like that. It's also another popular target in Cepheus for amateur imagers. This structure is often called the elephant's trunk. And I learned the other day that these little auxiliary things are sometimes called the caravan. So that's the elephant's trunk and the caravan in the stellar nursery IC 1396. This is pure space-based image, pure satellite astro imaging. It's actually a mix of visible light and X-ray images of the Crab Nebula pulsar, the very center of the Crab Nebula. When you add the visible light is from Hubble, the X-ray image is from the X-ray image data is from Chandra, X-ray Space Telescope, and when you add the X-ray image in, you can see this this sort of dynamo. This like structures. This is the pulsar, I think, right here. This central star here, and it's essentially spinning 30-something times a second, produces that rapid radio pulse 30-something times a second. Relativistic electrons spiraling along the magnetic fields generate this light, this visible synchrotron radiation, it's called, this visible light synchrotron. It's a very high energy object. And relativistic particles come out along the axis of rotation along this jet here. I was thinking about to me, this is one of the most amazing images that come out of the sort of space age of astronomy, as it were, high energy astrophysics. Thinking about the travel metaphor. So if you were in your starship, Star Trek or whatever, going, you would want to put the shields up when you got close to this. This is just a giant particle beam weapon in space. A cosmic particle beam weapon. So be careful there. Be careful when you go over there.
Yeah. Okay.
Oh well, here's some more good travel images. I don't know if you recognize this. This is a M51. The Whirlpool Galaxy is a bright spiral galaxy in near the handle of the Big Dipper, not far from the handle of the Big Dipper. Well known, often imaged. It's an amateur image of M51. It's a nice one. I see these little red dots along the spiral arms. Those are the star forming regions in M51. So these are the Eagle nebulas in M51. emission from hydrogen, ionized hydrogen in there. This is a companion galaxy up here that looks like it's just behind M51 because M51's spiral arm, the dust, it seems sort of leads in front of that, in front of the background companion galaxy. Interacting with M51. So this is an example of a galaxy interaction. Near collision, but you can always well, you can't, but if you could take your starship and fly around to the side of this system and look at this same system from the side, I think you would see something like this. On the left, this is like NGC 5194 or something. It's in Eridanus. That's why it's called Galaxies in the River. Eridanus is the river constellation. But here you're looking at M51 face on. Here you're looking at this spiral galaxy edge on. And so you see that it's narrow. This is the disk of the spiral galaxy. And this is the galaxy interacting with it. So this is this galaxy. It's actually behind the spiral as it falls into it. And in this view, we're sort of looking, we've flown around in our starship and we're looking from down here. We're looking up and to see it face on. It's an example of, I think this is the best we can do for a starship these days. And probably for a while. And this may be a familiar image to you. I don't know. This was a very famous image years ago from the Hubble Space Telescope. It was one of the first large images of nearby galaxies that they released. This is says 51 frame mosaic from the Hubble cameras of Messier 101, bright Messier galaxy. And it is just beautiful. And it was touted as one of the highest resolution images ever made of the galaxy. And I like to show this because in comparison with amateur images of galaxies, which amateurs could make by the 90s, I think. So this is a Hubble image of M101 from low Earth orbit. And it's not M101, it's the Andromeda Galaxy, and it's about 10 times closer than M101. But Robert Gendler did this 40 frame mosaic with his 12-inch Cassegrain from his driveway in Connecticut with with the image processing and the detectors that he could marshal at the time. So I think they're very comparable in detail. This is an example of the golden age of astroimaging. So I like this comparison. This was a 2.4 meter telescope in low Earth orbit. This was a 12-inch Cassegrain from a driveway in Connecticut. Just saying. I wonder if you've seen this. This is another Messier galaxy, Messier 74, M74. But this is an image that was very recently submitted to us by Robert Ader. He constructed it from JWST data. So this is a Webb Space Telescope image, a Webb telescope image. It's got, I think to make this, Ader has used two data sets from two of JWST's instruments. This MIRI is a mid-infrared instrument, and the NIR cam is the near-infrared camera on JWST. The near IR cam, this would be sensitive to the cool star population, radiation from the cool star population. The cool stars, the red giant stars, and Galaxy and M74. And Miri would be, I think, would be similar to the Spitzer Space Telescope band passes. It would see a thermal emission from the dust in the galaxy. So I think that's what you're looking at in the core of M74. I suspect this is about, I think I actually forgot to put this in my notes, but I think this is about the inner 30,000 light years or so across M74 from JWST. And Ader has downloaded data, publicly available data from the MAST website, the Space Telescope Archive website, and processed it with his, computers. I was so fascinated by the JWST image that I thought I'd throw these up for you. This is M74. This is a similar sort of central region of M74 from the Hubble Space Telescope. And this is one from Spitzer. So this is a bandpass. This is very similar to the, I think, to the MIRI, the mid-infrared imaging pass there. You can see how much, what a pretty stunning improvement it was. M74 is, Bill knows all about this. M74 is a famous grand design spiral. It's got two really pronounced spiral arms. And we see, of course, we see it face on really gorgeous view. I'll show you another web image. This was one of their PR images that they just released of a galaxy cluster. And it was touted, this is touted as Webb's first deep field view. I'm sure there will be others, but pretty amazing image. It's a cluster of almost all the little spots you see here are galaxies in this galaxy cluster. I'll let you read the phone number. It actually doesn't mean that much to me. It's just the coordinate based name from this catalog. Is it 5 billion light years distant? It's interesting. So the little splotches you see are the cluster galaxies, right? But the cluster members. But of course, these big spiky stars are in the Milky Way. They're seriously foreground objects, and easy to recognize because they have this. They have the 6 spikes. I think you should, if you like James Webb, if you like Webb Space Telescope images, you should get used to seeing this 6 spike diffraction pattern, because this is what the Webb mirror looks like. In this top inset here, this is their telescope alignment evaluation image on a reasonably bright star. You see the star has the 6 diffraction spikes. That's not really a bad thing. That's a good thing. When you see the diffraction spikes, you know you've aligned all of the James Webb mirror segments as well as you can to give a diffraction limited picture. And the 6, these are hexagonal mirror segments, which basically translates into a 6-sided aperture operating coherently, and so it produces 6 diffraction spikes. Other structures within the telescope will produce other little diffraction spikes, but you'll recognize the Webb images when you see the 6 diffraction spikes from the stars. The streaks in this image, of course, are galaxies too, but they're galaxies beyond the galaxy cluster. They're lensed by the gravitational mass of the cluster, which incidentally is dominated by dark matter. It's not, if you just add up the mass of all the clustered galaxies you see in the picture, you don't get enough mass to gravitationally lens the light from the distant background galaxies that you see here. That's a prediction of the general relativity. And it's a good thing for us. The gravitational lensing lets you see what even more distant galaxies look like beyond the galaxy cluster that you're looking at. That's what these arcs are, what I'm talking about, if I haven't been clear, are actually distorted images of distant background galaxies. In fact, I think these two arcs are probably from the same galaxy, just sort of mirror images from the same galaxy, mirror lensed images from the same galaxy. How are we doing on time, Bill?
Another 10 minutes.
Okay. Well, okay. Maybe okay. So let's play a little game. I'll explain this picture to you. This was also a contribution, an amateur contribution, as it were. This is the Mona Lisa. I hope you recognize it. These pixels are created from images, just images of the moon. Just in fact, Marcello Giulia Pacha took the lunar images over the course of a year or so, I suppose. And so all of the pixels that are used to construct that are just natural colored images of the moon. I mean, how far above the moon, is it above the horizon? Is it in eclipse? What phase is it at? The moon can take on all sorts of different colors of a full moon. You can see you'll recognize the picture, I think, if you either stand way back from your monitor or just look at the smaller and smaller versions of the picture there until you sort of recognize the general outline of the Mona Lisa, Leonardo da Vinci's famous painting. Turns out Da Vinci has another connection to the Mona Lisa, and that is the dark pixels here are the moon. When the moon's surface is dark like this, it's sort of dark bluish. It's that's the moon surface illuminated by Earthshine, right? That's light reflected from the moon. Light reflected from the Earth, illuminating the night side of the moon, the shadowed side of the moon. That's why you can see it, I think, particularly in the spring. It's an effect that you often see. You can sort of see the shadowed side of the moon, the dark side, the night side of the moon, slightly illuminated. That's illuminated by Earthshine. And Da Vinci actually, I think, is recognized as the first to suggest an explanation for moonshine, or for Earthshine. Da Vinci was the first to suggest, 400 plus years ago, that Earthshine was light reflected from the Earth. He thought it was reflected from the oceans of the Earth, but I think it's reflected from the cloud cover, basically. But still, it's the Mona Lisa. I'll just stop there. Oh, well, it doesn't matter, Bill, because I got to the end.
Okay.
I often, just as I often start with the postcards from the universe, I often end with the Chelyabinsk meteor flash, because it reminds me so much of the end. This was years ago now, in the airburst of the meteor over Chelyabinsk, Russia. I don't know if you read about this or remember this at all. It did a lot of damage to Chelyabinsk. And Marat Amatveyev is an amateur photographer who got up early that morning and went out to walk along the river because he knew it would be cold. It had been very cold and it would be very frosty, and he thought he could take really interesting pictures of the frost on the trees, the frost on the bare trees. So that's sort of why this is framed like this. This is the best picture of the flash. We had many images submitted of this flash. Actually, most of them were from dash cams and security cameras that happened to pick this up that morning. But Murat was out with his with his full up camera setup, and he said he felt the heat on his cheek and turned when he had the camera up. He felt the heat on his cheek and he turned to look and recorded this image of the Chelyabinsk meteor flash. And that's the end, Bill.
All right. Well, that's certainly a promising way to end. Let me see. What do we want?
What do I do now?
Side by side gallery. There we go. Okay.
How about that?
That brings up a question. You've stuck mostly with the static pictures.
Yeah.
And that was an executive decision, I'm sure.
Yeah.
But it must have been so tempting so many times, especially like with that meteor flash, that fireball, to incorporate video.
Yeah, we do that. We do videos. I confess that I felt technically challenged enough to put this presentation together with a very simple PowerPoint that I didn't want.
Yeah. Oh, okay. So it's worth saying that Astronomy Picture of the Day also includes videos.
Absolutely. Absolutely.
So open it up for any questions. We don't forget to unmute yourselves, and we'll take it from there. There are a few chat items.
Do I see the chat? Can I see the chat?
Yeah, it's down at the bottom. There's a chat thing. Virginia mentioned something about a fantastic image. I don't remember which image it was.
His frost images were photobombed. Yes, they were pretty bombed.
And then the picture of Mars atmosphere. You were wondering what was a better color word?
Ochre.
Ochre. Yeah, I suggested mauve, but I think ochre is better.
I have this problem naming things these days, and sometimes I just can't get it off my tongue, as you may have noticed.
You're doing fine.
Ochre had occurred to me, but I couldn't say it for some reason. I apologize.
Oh, we need some artists. And then Virginia asked about the comet coma being green, and you recommended that it was a diatomic.
Diatomic carbon molecule.
Yeah.
C2.
And the
Mars is definitely ochre, not mauve.
Okay, definitely
Yeah.
ochre. We've got an artist here. Artist scientist.
Not mauve, not mauve.
Never mauve.
Jerry got it right.
See, my wife is an art historian. I'll get her, if you're not careful, I'll get her in here.
Oh, okay. That would be fun.
He
And
said ochre, yeah?
Yeah.
Yeah. Yeah.
and
We're on board.
here's a plug on the Rosetta.
Yeah.
Joel Parker in Colorado gave a fabulous presentation on the Rosetta mission to comet CP 67.
67P.
67P. Bill noted the shape of the comet nucleus as being dumbbells.
Yeah, dumbbells. That's a better one. Yeah.
And then he also mentioned that there was a prior detection of a planet around a normal star being Gamma Cephei in 1987. Does that ring a bell?
I don't want I don't know, Bill.
Yeah, I don't
Yeah.
know.
What I was thinking was, what I was trying to be careful of was the pulsar planets.
Right.
That was in 92, yeah. That was published in 92, Frail and Fullscan. But the one
Yes.
in 1987, that was there was a couple of astronomers at DAO on Vancouver Island did some work where they published their result and they presented at a meeting, and everyone was too skeptical about it. So they lost their nerve and they withdrew the paper, which is too bad because it was confirmed later on.
That's a shame.
Well, maybe I could just add the word confirmed to my statement. The first confirmed exoplanet around a sunlight star. You start to have to qualify these things too.
This is high stakes. They missed out on the Nobel
Oh.
Prize.
Yeah,
Poor guys.
I know.
All right.
Are the Oort cloud comets, are they like, do they come into our, come towards the sun because they're
Are
knocked
influenced
into
by, yeah, they're influenced by maybe other in the distant past over, they're influenced by close encounters with other stars, maybe different environments as the sun moves through the galaxy, as the sun orbits the galaxy. They're far enough out that they are disturbed and can head in. Can.
So it's not just other Oort cloud objects that are
I don't
causing,
think so.
okay,
There's molecular clouds out there as well
yeah,
that can stop a comet dead in its tracks and it'll fall in.
Huh.
Let's see, anything else? The M74, the new web picture showed circular voids. And
It
those are
did.
very
It looks
fast.
like honeycomb to me.
yes.
Yes, a honeycomb, yes, but very circular.
And so did the Hubble and Spitzer images, but just vaguely, barely.
Yeah.
I could try to put those slides back up, but do you want me to?
Yeah.
Here. It's just complicated. So I have to share my screen, right? Share screen.
Yep.
And now, if I do this slideshow from the current slide, thank you. So these sort of voids that look sort of like honeycomb. These
Yeah.
things, right?
Yeah,
I see bigger ones to the lower left.
yeah.
These
Yeah.
left,
Oh, well,
the other
wow,
left.
right.
These
No.
guys,
Lower right, I meant.
Over there.
Sorry.
lower right.
Yeah.
Yeah,
Okay,
you got
but
it.
look at this.
Both.
Okay, guys, wait. Look at this. See,
Yes.
these are dust. This is dust. These are dust lanes in the Hubble image. Are those really not there? These are, Bill. This is the Spitzer
might
image,
be.
which is like the I
Yeah,
claim like
yeah.
the MIRI,
Fantastic.
the mid-infrared data.
Yeah, but when
We
you look
have
towards
that.
the center there, it looks almost like you have this patterns of a seashell, right?
It does. It
Did
looks.
it
I was thinking of a nautilus,
Here, you
right? The
see.
chambers of the
Yeah.
sort of two nautili.
See the-
Well, that's it for the chat. Any other
But
questions?
that's all I got, really. I can guess what we're looking at because of where the filters are in these cameras, but
Right.
Oh, sure.
I don't know. I don't do galaxies, Bill. I don't.
Yeah, well, it's certainly promising. Just the fact that this fellow was able to access an archive that already exists.
Yeah,
With
we have a lot of right now. We have a lot of submissions of this style, not necessarily this object, but public data down from JWST downloaded and processed by.
Yeah, it's incredible.
So you
is
don't
there-
have to search for images. They just come to you, I guess.
I missed that.
You don't have to search for images and put them on. You just they come to you.
I'm overwhelmed with the submissions that come to me. I don't. Yes.
Nice.
That's right.
Wonderful.
It's not a bad thing to be. not a
No,
bad
it's
thing.
not. It's not.
And it's a wonderful thing to put on as your go-to, when you go to your Firefox or Chrome. And that's the first thing that comes up for me is Astronomy Picture of the Day. And that gets my
Yes.
day going. Just saying.
Yeah. Good.
That's my
So-
screen.
I want to
Thank-
thank you, Jerry, and
Sure.
I look forward to spending cooler weather with you in Greenbelt
Sure.
within the next year or so. Thank you for being willing to present all this good stuff. It's quite a
Thanks.
legacy.
Thank you,
Thanks for
Thank you.
having
Thank
me.
you.
Very much.
thank you,
Thank you.
Jerry. Thank you, Jerry, and
Thank
thanks, Bill, for inviting us.
All right, as always, keep the
Yeah,
faith.
we really
Thank you.
appreciate it.
Thank you.
Thank you, Jerry.
All right,
Good.
take care, guys.
Okay.
Bye.
Good night, guys.
Stop recording.